record. And now, my man, we can do assignment number 48, problem number.
I may have a lot of questions.
I'm just going to record everything I explained, so that's that. So the first thing that we would do is we would add 6 to both sides.
Yeah.
And then we would divide by -6. So anyways, I'm just going to skip one step. But if I just add 6 to both sides, I'm left with -6 times 10 to the power of 9 minus 3b, and that will equal -50.
Yeah.
And then when I divide both sides by -6, I get 10 to the power of 9 minus 3b equals a decimal that I don't want any part of.
No,
Got
it'd
it?
be just it'd be 50/6, right?
You could put 50/6. We could reduce it to 25/3. Let's just leave it as 50/6, because at the end of the day, the calculator doesn't care if we reduce or not. Like, we're going to use it.
So it'd be log 50/6. When you type it in, it'd be log over.
Hold on, no, don't get ahead of me. I want one more step on our paper before we grab the calculator. Because you try to do too many things, I think, and that's where you get in trouble. So what are we doing to both sides right now?
We're going to log both sides.
So what's it going to look like after we do?
It's just going to be 9 minus 36 equals
9 minus 3b.
Yeah. That'd be.
And you understand that's because the log of 10 goes away, right?
Yeah.
Okay, bud, good. So then we have the log over here. So this is a proper amount of work to show. It's at this point that I would expect to not see anything else. So walk me through this. You're thinking, what are you typing in?
I'm going to do the log of 50 divided by 6.
Good job. I'll do that with you.
Subtract 9.
Good job. And you
get -8.
Good job. So you did hit enter, right?
Yes.
So after you subtract 9, good.
You divide by 3.
That's not a 3.
A -3.
That's good. And you and I should agree that the answer is
2.6930.
It's 2.6931.
6 go to a 7 because of the 9.
We are rounding to 4 decimal places. And so the rounding that occurs, anything that occurs in this region is not of any interest to me because I'm not rounding to that. You must understand that when we're rounding to 4 decimal places, I need you really to listen, okay? If we're rounding to 4 decimal places, what helps some people when they're first learning rounding is draw a wall right after what you're going to round to and just say, okay, that's where the interesting stuff is. So if I'm going to round to this decimal place, I only need to know one more digit. So I don't need to know anything else. Do you understand that?
31. After the 3 instead of 7.
Right. So the 6, the 9, and the 3 generally are not going to be involved in this. What's going to happen is what's that 6 going to do to the 0 that we're interested in? And that's why we get 2.6931.
Okay.
Tristan, if we were rounding to the nearest, say my direction says that round to the nearest 10th, 1 decimal place, then
it would just be 2.7.
Then it would be 2.7, right? Because then this 9 and this 6 get to play together because they're where the actions happen.
Yeah.
Got that? Okay, good. So this is number 2.
Yes.
So yeah, if we add 10, we get 87.5. If we divide by 6, we should look at this. We should have 15 to the power of 7x equals 87.5. Now, this is where I just don't want you to skip this step routinely because I don't know what to say other than that, like, you're going to get yourself into a dangerous position where if you're not seeing it with clarity, like when to put parentheses in the calculator, when not. Anyways, the only time I would advise you to just totally jump ahead here is if this is a 10 or if it's an E. Then those are the ones where we can log or natural log and make something go away, and then we just jump right in and go. But in a case like this, and you know by now that I don't tell you to show things because I just say, kids are supposed to show work. I would always tell you that it's in your best interest.
Just going to show log of 15.
So what we're going to do is we're going to bring the 7x down. I don't mind if you skip this step, like bringing the exponent down and logging at the same time. That's okay with me.
So I just have to show my log part.
So I'm going to put 7x times the log of 15 equals the log of the fraction. And I think, like I said, that there's a decent chance that you might have gotten to the right place. But in a case like this, what we want to do now is we want to get x by itself. And so this I would be happy if this was the last bit of work I saw in your paper, because you wind up having to take both sides now and dividing by 7 log of 15.
Okay, that makes more sense.
Because the nature of this particular type of problem is that you've got these two clingers. The 7 is a clinger and the log of 15 is a clinger, and those clingers can only be detached by division. And so I figure, well, heck, we might as well divide by both of them at the same time. But we're still not out of the woods, because what happens is, if we're not careful with how we put this in our calculator, the calculator is going to give us it's not going to mess up. We're going to mess up. It's going to give us something that we're not looking for. Mm-hmm. So when we go to type this in now, this is the one where we do log of 87.5. And then you just divide by 6 and close your parentheses. And then we hit divided by. And do you remember what we have to put after that division sign?
It's like a divided by a set one parenthesis.
There you go. And that's there you go. I'm proud of you. You got to have this manual parentheses to force the calculator to divide after it's done multiplying.
15.
We sort of take control of the order of operations by using parentheses. Parentheses are so rad.
So yeah, that's when you have the double parentheses, right?
Yeah. So in yours, it's going to look like that. You're going to have the
0.1413.
And you're happy with that 3 in the fourth place? What was after the 3?
7.
So was it a 3 and then a 7?
Yeah.
And it needs to become a 4, Tristan. You can't ignore the 5th place. When you round to the 4th place, you must look at the 5th place. He will determine what you do with the 4th place. Got it?
Got it.
Okay. I get that. So when you divide on your calculator and you get 0.9649735,207. So the idea here is, once again, I encourage you, if you're going to round to the 4th place, draw a little wall right after it and just remind yourself that all the action's going to happen in this vicinity, right?
Yeah.
And also be advised that you don't need all of this stuff. You only need the one place after. That's all you need.
Yeah.
Okay. So your question was, if this 7 rounds this 9 up to a 10, what effect does that have? Well, see, this is just a digits place, this 9. It doesn't have enough room to hold 2 digits, a 1 and a 0, right? Mm-hmm. So what happens is, when it rounds up to a 10, it actually rounds up to a 0, but then the 1 part of the 10 carries one more spot over. So it winds up that we have 0.9650.
Okay.
You follow that?
Yeah.
Whenever a digit moves up to a 2-digit number, and the only way that can happen is for a 9 to become a 10, this one becomes the 0, and then we add 1 to the spot.
Mm.
Got it?
Got it.
Sweet.
That makes more sense.
Awesome. Blossom.
Thank you.
You're welcome.
I'll take a look.
Number 9, you say? Yeah. Yeah. So what we're going to do, so we're going to start by subtracting 9 from both sides. So this is practice quiz problem number 9. And so if we subtract 9, we get -61. And then if we divide both sides by -4, we wind up with e to the power of 7x plus 5 equals 15.25. Do you understand why I would put a decimal there and not leave it as a fraction? Yeah. So here it goes. What are we going to do to both sides? Good for you. And the benefit of natural logging is that the natural log of e is going to go away, and the left side winds up just being 7x plus 5, and the right side is the natural log of. So imagine Blair, for a second that I gave you this equation. I'm going to change colors just to point out that this is a bit different. If I gave you that equation, what would you do? That's what we're going to do. You get that, right? So your issue is just maybe I'm not putting it in my calculator correctly. So you and I are going to type in the natural log, and then it's going to give us parentheses, and we're going to put in 15.25, and then we're going to shut them down. And then we are going to subtract 5. And at this point, it is massively important right here that you hit equals or enter on your calculator. You must break up the order of operations. You need your calculator to calculate the answer to that before you hit divided by, right? Otherwise, it's going to jump ahead and do the division. We don't want it to. So hit enter, and then leave that number on your screen and just hit divided by 7. And you understand that what your calculator is going to do is then it's going to take that 5 divided by 7, and you're like, whoa, 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 don't do that. Like, we got to tell it not to. And FYI, Blair, another way, if you don't want to hit enter, another way to do this would be you could put in your own manual parentheses and then just hit divided by 7. And that way there you, because you have to somehow tell your calculator to subtract before.
I have a question on number 5 on number 48.
Number 5 on number 48.
I mean, assignment.
So this is assignment number 48. And this is problem number 5.
I got a whole number instead of a decimal. I don't know if that's wrong.
Interesting. Let's see. So if we divide by 5, I'm not seeing it. So I assume you divided by 5, right? Are you on problem 5 of assignment number 48?
I wrote the wrong number 5 down.
Dope.
I looked at the 5 on this one instead of this one.
So are we going to do this, or should I just cut this off?
We should do that one.
Let's do it.
Let's do it together.
Hold
on, let me get caught back up. Thanks. Me thinking, I look at the practice quiz instead. I'm gonna take that.
Oh, yeah. Give me a minute. Okay.
You divide by 5, which I'm going to check this real quick.
And this one you can tell is probably going to come out good because the
it's
nature.
18.3.
Say it again.
It's 18.3.
Yeah, that we like that. So now if we divide, then we get a nice number. We get 3 to the n minus 3 equals 18.3.
Yeah.
And we like that decimal. And then now we do what?
We do n minus 3 times the log, parentheses, 3, close parentheses.
Make sure your parentheses go around the n minus 3. I was just telling this to Sebastian a little bit ago that when that exponent has more than one like plus or minus part, it has to travel down, but it travels in a package and it has to stay as a package like this. Okay.
Which equals the log 18.3.
Good. Now just think about the math. In what order do we have to begin picking away at it to get n by itself?
We have to do the log of 18.3 divided by the log of 3, close by parentheses, and then subtract the negative 3.
Just add 3.
Oh, I mean add 3, my bad.
Right. And then that's it. You're done. Nice. Good job. You good then, Tristan?
Yeah.
Okay.
I can't believe.
Oops. Oh, I think my board might be dead. Oh, look at that. It finally just it gave up. Hold on a second. Let me pause the recording. There's hoping we're Zoom. So all right, again, assignment number 48. Problem number 9?
8.
I knew that. 8. So 8's going to be pretty straightforward just because the nature of what it is. So when you have 18 to the power of n equals 13. This should be a real quick one. We're just going to log both sides. So it winds up being n times the log of 18. equals the log of 13. If you ever wonder, like, what do I do? The answer to the question, you could ask me this 1,000 times, and my answer is going to be get the power by itself, get the power by itself, get the like over. Like I just have a button that says that. Uh, and since there's nothing added to it, nothing multiplied by it, it's like it's just ready to rock and roll. So you just type in log of 13 divided by log of 18. Done. Got her?
Yeah.
All right then. Problem number 9. And when I get caught up to you and I add 5, I get negative 50. And then when I divide by a negative, we should agree that it is 3 to the power of negative 3.6n minus 2, and that should equal 50.
I just forgot to divide by my negative.
Saying I just forgot to divide by my negative is like saying I just forgot to put the car in park when I got out to go to the grocery store. Like, don't dismiss that like it's a minor detail. If there is a negative in front of this, then the power is not by itself.
No.
You have got to get this by itself, and sometimes even just a negative. You got to get rid of it. Sometimes it's a regular number, like a 5 or a 4, whatever it is. You got to get rid of it. Got it? Okay, so now that we've divided by a negative, it's business as usual. We're going to log both sides. We're going to bring that exponent down. And that's it. I mean, I say that's it, but that's really where I would expect to probably stop seeing any work on your paper. What order are you doing this?
I'm doing the log of 50 divided by the log.
And then go ahead and hit enter at that point.
Well, I have to add 2.
And then hit enter. That works for me. Sure.
You get 5, and then you divide by 3 points. Negative 3 points.
Yes. Mm-hmm.
Negative. $15.4 5.